Frictional force. The frictional force is a component of the force that a surface exerts on an object with which it is in contact. It's the component that's parallel to the surface. If you recall, the normal force is the perpendicular component of the force that a surface exerts on an object with which it is in contact. So with our book on the desk, the normal force from the desk is directed upward, perpendicular to the desk and opposing the weight of the book. The frictional force is the parallel component of the contact force from the desk to the book. So any frictional force from the desk to the book will be directed parallel to the surface of the desk. If there is no force being applied to the book to move it across the surface of the desk, it is not accelerating, and the magnitude of the frictional force is also equal to 0. This is because forces in a direction must be balanced if there's no acceleration along that direction. Let's say we tie a rope to the book and apply a pulling force on it to the right in an attempt to move it across the desk. If this force is not great enough to actually move the book, the frictional force from the desk to the book is called the static frictional force, F sub s. The word static implies no movement. Just because there's no movement, it doesn't mean that the magnitude of the static frictional force is 0. If there's no pulling force, or the pulling force is equal to 0, then the static frictional force is also 0. This way, forces are balanced and there's no horizontal acceleration. But let's say our pulling force to the right has a magnitude of 9 newtons, which is not enough force to actually move the book. The book is still stationary, not accelerating. Since it's not accelerating, Newton's second law tells us that the net horizontal force on the book must be equal to 0. In order to have 0 net horizontal force on the book, the static frictional force must also have a magnitude of 9 newtons. Between each pair of objects, there's a maximum allowable value for the static frictional force, Fs max. Once the magnitude of our pulling force becomes greater than the magnitude of Fs max, the net horizontal force on the book is no longer 0. The forces are no longer balanced, and the book accelerates to the right. The coefficient of static friction tells us more about the static frictional force. The magnitude, F sub s, of the static frictional force can have any value from 0 up to a maximum value of Fs max, depending on the force applied. In other words, Fs is less than or equal to Fs max. The maximum value for F sub s is Fs max equals mu sub s times F sub n, the normal force from the surface. Mu sub s is the coefficient of static friction. It relates the maximum static frictional force and the normal force. We can calculate a value for the coefficient of static friction by dividing the magnitude of the maximum static frictional force by the magnitude of the normal force. Since this gives us newtons divided by newtons, the coefficient of static friction does not have any units. Once we have movement between two objects in contact with each other, the frictional force opposing the motion is called the kinetic frictional force. The word kinetic suggests movement. The magnitude of the kinetic frictional force can be found by multiplying the normal force by mu sub k, where mu sub k is the coefficient of kinetic friction. So between two objects in contact with each other, we consider the static frictional force to apply when there is no movement between the objects, and we consider the kinetic frictional force to apply when there is movement between the objects.